Okay, welcome back, students. We're going to jump into section 2.1, chapter 2. Chapter 2 is on acute angles and right triangles. Let's go ahead and begin. Okay. Okay, make sure that you're downloading your notes and you're following along with the notes. You will be using your notes on the quizzes and exams, so make sure that you take really good notes. Okay, trigonometric functions. Okay, right triangle based functions. We have sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent, opposite over adjacent for my right triangle. The cosecant is hypotenuse over opposite. It's just the reciprocal of sine. The secant is hypotenuse over adjacent. That's reciprocal of cosine. And the cotangent is adjacent over opposite, which is the reciprocal of tangent. Mnemonic device that we use in trigonometry is SOHCAHTOA. SOHCAHTOA. Okay, that's Native American for right triangle. It's not, I'm just kidding. Okay, SOHCAHTOA. The S is sine, and that is opposite over hypotenuse. So that's the SO. A cosine is adjacent over hypotenuse, so that's the CA. And the tangent is opposite over adjacent, or the TOA. Okay, and so if we look at a right triangle, oops. Okay, if we have the angle here, well, what's the opposite side? The opposite to that angle is here. That's the opposite side. The adjacent side is the one that makes up the right angle, but is adjacent. Adjacent means next to or touching. So this is the side that touches the angle, but isn't the hypotenuse. So the adjacent side is here, and the hypotenuse is the longest side. The hypotenuse is the one that's opposite the right angle. Okay. Okay, example 1, find the sine, cosine, and tangent values for A and B. Okay, so the sine of angle A, sine is opposite over hypotenuse. So if I look at my angle A here, okay, opposite to angle A is 36. So that's going to be 36. And the hypotenuse is 85. So that's going to be 36 over 85. Okay. The cosine of A, that's going to be the adjacent over the hypotenuse. And so for angle A, the adjacent side is the 77. It's not the 85 because that's the hypotenuse. Okay, the hypotenuse, again, is always opposite the right angle. So this is going to be the adjacent side is that AC. So that's 77 over 85. And the tangent of A, that's going to be the opposite over the adjacent. So opposite over adjacent. And so the opposite is 36, the adjacent is 77, so I'm going to get 36 over 77. Now the sine of B, okay, is going to be 77 over 85, because for B, the 77 is the opposite side. Okay, if I change my reference angle, okay, to refer to angle B, then what's opposite angle B is 77. And then what is opposite over hypotenuse? Opposite is 77, hypotenuse is 85. So this is 77 over 85. The cosine of B, Okay, that's going to be the adjacent. Well, the adjacent of what? The adjacent of angle B. So the adjacent here is 36, and the hypotenuse is 85, and then the tangent of B is going to be the opposite over the adjacent, or in this case, 77 over 36, and that's the tangent of B. Okay, write tangent 23 in terms of its cofunction. Okay, well, what's a cofunction? Well, the cofunction identities are down here. Okay, the sine of A is equal to the cosine of 90 minus A. So if I take the complement of A, okay, which is 90 minus A, then the sine of A is equal to the cosine of its complement. And we kind of can see that from our right triangle, in that if angle A, let's give these angles some, let's say that angle A here was, I don't know, 30 degrees. Okay, then how would I get angle B? Well, I would get angle B by subtracting 90 minus 30, because the angles in a triangle have to add up to 180. So if the angles in a triangle have to add up to 180, and I already have a 90-degree angle, then 180 minus 90 is 90. And so then I can say, well, okay, now A and B have to be complementary angles. Angle A and angle B have to both add up to 90 degrees. So I'm going to subtract 30 and I get 60. And so what this is saying is it's saying that the sine of 30 degrees was equal to the cosine of its complement, which is 60 degrees. Okay. And we can see that in the triangle that, yeah, if angle A is 30 degrees and angle B is its complement, 60 degrees, then the sine of A, which is, let me highlight that, the sine of angle A, which was 36 over 85, is equal to the cosine of B, which is also 36 over 85. So we can look at these relationships and say, oh yeah, you know, if the sine of an angle is the cosine of its complement, and vice versa. The cosine of an angle is the sine of its complement. Okay, so the cosine of that angle is the sine of its complement. Okay, sine of an angle is the cosine of the complement, and the cosine of the angle is the sine of the complement. We want to write 23 degrees in terms of its cofunction, tangent. Okay, so let's go to the one that involves tangent here. Okay, that's this guy. And it says in terms of the cofunction, the cofunction of tangent is cotangent. Okay, so we're going to say that the tangent of 23 degrees is equal to the cotangent of 90 minus 23. Okay. And so 90 minus 23, I believe that is 67. Let me just check. Yep. Okay, 90 minus 23 is 67. So this is the cotangent of 60. So the tangent of 23 degrees is equal to the cotangent of 67. And you could check that on the calculator if you wanted to. Okay, maybe we'll do that real quick. Let's check this on the calculator. If I have the tangent of 23 degrees, okay, then that should be equal to the cotangent of 67. Well, how do I find cotangent? Well, cotangent is the reciprocal of tangent. Okay, so I can go 1 divided by the tangent of 67, the complement, and oops. 1 over the tangent. Oh, you know what? I think I have this in the wrong mode. This should be in degrees mode. Make sure that you have it in the correct mode. Okay, how do you get your calculator in the correct mode? Clear. You just hit mode, which is the second, next to the second button at the very top. Okay, it's right here. Okay, second and then mode. And then you're going to arrow over to degrees, down to degrees. You're going to hit the little arrow cursors and then go over to degree, radian, and hit degree and then hit enter. And make sure that that one's flashing now. Okay, and highlighted. And now what we do is we go second and then mode. Second to quit out of mode. Second mode, and then we quit. So now let's go back and do these. The tangent of 23 is that. Okay, that's in degree mode. Okay, and then the 1 over, what I can do is I can just kind of copy and paste this. I can just go enter like that, and we get the same number. Now, there is a button that will give you reciprocals on the calculator, and that is the x to the -1 button, but don't get this confused. This is a reciprocal button. This is not an inverse button, and we're going to talk a little later about inverses. This is the reciprocal button. So say that I wanted the tangent of 67, but I wanted the reciprocal of that. I wanted the cotangent. So if I took the tangent of 67, okay, and then I reciprocal that, that gives me the 0.42. It's the same thing as doing 1 over. It's anything to the -1 power is just 1 over itself. Okay, so a little algebra cheat there. Okay, and that's the x to the -1. It just inverts. Okay, it reciprocates, I should say. Okay, it reciprocates what I wanted. So if I want to find cotangent, I can reciprocate that. If I wanted to find cosecant, I could say, what's the sine of 23? And then to the -1 power. And that gives me the reciprocal of the sine, which is the cosecant. Okay, so a little calculator tricks there. Let's go back to my notes. Okay. Okay, number 3, example 3, find one solution of the secant of 5 theta plus 14 equals cosecant 2 theta minus 8. Okay, so we know that the secant of an angle is equal to the cosecant of its complement. Okay, so the secant of the angle is equal to, I'll put angle A here, is equal to the cosecant 90 minus A. And so what I'm going to do is I'm going to change this guy here into cosecant 90 minus A. Okay, so I'm going to erase that real quick. Okay, so this is going to be cosecant of 90 minus this angle here, 5 theta minus plus 14. So this is 5 theta plus 14. This should be cosecant, sorry, cosecant. Okay. Of 90 minus 5 theta plus is equal to cosecant of 2 theta minus 8. Okay, so now I have cosecant equal to cosecant, so I can kind of ignore the cosecant and just deal with the numbers inside the parentheses. And again, where am I getting the secant to cosecant? It's right here. Sorry, it's right here. Secant is equal to cosecant 90 minus A. Okay. Okay, so now we're going to do 90 minus, I'm going to distribute this negative sign. So when I distribute the negative sign, I go -5 theta minus 14 is equal to 2 theta minus 8. So 90 minus 14, that's going to be 76. So 76 minus 5 theta is equal to 2 theta minus 8. Okay, and then if I move the 5 over there and I move the 8 over here, okay, I'll get 7 theta is equal to 84. And so theta is equal to 12 degrees. Okay. Let me make that theta a little nicer, 7 theta. Okay, note, as an angle A increases from 0 to 90, y increases and x decreases. Okay, so as the angle gets bigger, y is going to get bigger, okay, than x. Okay, so we could say that if an angle is less than 45 degrees, if theta is less than 45 degrees, okay, then y over x is the y over x, that's going to be less than 1. Okay, if theta is equal to 45 degrees, then y over x is equal to 1. And if theta is greater than, I should say theta is between 45 and 90 degrees, then y over x is greater than 1. Okay, we're going to use this in our next problem here. So to determine whether the statement is true, the cotangent of 15, okay, is less than the cotangent of 70. Okay, so the cotangent was of 15 degrees, okay, is that less than the cotangent? Well, what's cotangent again? Let's think of what is cotangent. Cotangent, let's go back up here. Cotangent was adjacent over opposite. So adjacent over opposite. So if I look at a 15-degree triangle, okay, so this is 15 degrees, then x, or sorry, y is going to be much smaller than x. Y, so this guy here for cotangent, okay, this is going to be adjacent over opposite. So the adjacent is x. Okay, so the adjacent side is the x. The opposite side is the y. Okay, so we want the x over the y. Notice that the x for 15-degree angle, the x is much bigger, okay, than the y. So x over y, well, that's going to be, okay, that's going to be x over y is going to be greater than 1 here. So we can say the cotangent of 15 degrees is greater than 1. Okay, why? Because x over y, okay, x over y is going to be bigger than 1 because we're going to have a big number over a small number, and that's going to be bigger than 1. Okay, so cotangent is greater than 1. Okay, and what about the cotangent of 70 degrees? Well, let's look at a 70-degree angle. So 70 degrees, and here we have y over x. And notice that in this case, the x is smaller than y. So in this case, due to the cotangent, the x over y, I know it's kind of backwards from what we had previously wrote here with the y over the x. Y over the x is the tangent. The cotangent is the reciprocal. So the inequalities get reversed if it's cotangent. Okay. So for cotangent, this is going to be less than 1. So x over y is less than 1. So is something that's bigger than 1, okay, bigger than 1, this is cotangent 15 is greater than 1, is that less than something that's bigger than 1? Or sorry, that's yeah, is it less than something that is, sorry, smaller than 1? Okay, the answer is no. The cotangent of 15 is going to be less than 1, and the cotangent of 70 is going to be greater than 1, and the cotangent of 70 is going to be less than 1. And so something that's smaller than 1, think of like, you know, a decimal like 0.69. Okay, that's going to, and if you have a number that's greater than 1, think of like 2.5. Okay, is 2.5 less than 0.69? No, it's not. So this statement is false. Okay. Okay, let's finish up this section with the functions values of special triangles. So what are the function values of special triangles here? Well, the sides of a 30, 60, 90 triangle look like this. If I have the opposite to the 30-degree angle is 1, the hypotenuse is 2, and using Pythagorean theorem, I can get the adjacent side to be radical 3. Okay. So let's work on the 30-degree angles and the 60-degree angle here. So if I wanted the sine of 30, that would be opposite over hypotenuse. That would be 1/2. The cosine of 30 is radical 3 over 2. That's the adjacent over hypotenuse. And the tangent is going to be 1 over radical 3, which if I take 1 over radical 3 and I multiply it by radical 3 over radical 3, I get radical 3 over radical 9, which is radical 3 over 3. So I rationalize the denominator. So this is radical 3 over 3. Okay, what about 60 degrees? Let's change the, whoops, I don't want to change those. Okay, let's change the angle that we're looking at for the sine that's opposite over hypotenuse. So that's radical 3 over 2, okay? Or what cosine was in the previous angle. Cosine, the sine of the complement is the cosine. So we kind of just swap these like that. Okay, this is 1/2. We could see that that's adjacent over hypotenuse for the cosine. The tangent is going to be radical 3 over 1, which is just radical 3. Radical 3 divided by 1 is radical 3. Now, what about for 45 degrees? Well, for 45 degrees, if I have a right triangle, okay, with a 45-degree angle, let me draw a big right triangle. Okay. Try to draw this well. Okay, so we have a right triangle, and if it has 45 degrees here, then it has 45 degrees here, because they have to add up to 90, and because it's already a right triangle. And there's a theorem in geometry that says opposite sides correspond to opposite angles. So if you have angles that are the same, then the sides opposite them have to be the same. So I'm going to let this be 1. I'm going to let this be 1, and then I'm going to let this be radical 2. Okay. And so I go 1, 1, and then radical 2. How do I get radical 2? Well, again, that's Pythagorean theorem. Okay, just 1 squared plus 1 squared is 2, and then take the square root to get, think of it as our r. Okay. So what's the r there? Well, it's just x squared plus y squared, right? Okay. Okay, so now we can do the sine here. The sine of 45 is 1 over radical 2. Okay, sine of 45 is 1 over radical 2. And it doesn't matter which 45 I use, it's going to end up being the same thing. So 1 over radical, again, I want to rationalize that. So 1 over radical 2 is equal to, multiply by radical 2, that's radical 2 over radical 4, which is radical 2 over 2. Okay, so this is the sine is radical 2 over 2. And if I do the cosine, I get the same thing. It's 1 over radical 2. So that's radical 2 over 2. And then if I get the tangent, well, the tangent is just going to be 1 over 1, which is 1. So that's the nice property about 45 degrees is that the tangent is 1. Okay, so that's very nice property. Tangent of 45 is 1. Okay, that's 2.1. I'll see you in the next section.